Hello everyone, I am Mrs. Rushali Chaudhary, lecturer Pravit Patil Polytechnic welcomes you in the first year of diploma. We are going to learn basic science chemistry, chapter 1 chemical bonding and catalysis. The outcome of this chapter is to apply the catalysis process in a industry and learn the chemical bonding which is required for the various applications. What is a chemical bonding? Did you know how many elements are present in a periodic table? Yes, the number of elements present in a periodic table, but number of molecules present in a environment or in a world is a lakhs. How that is possible? Because this element single atom will combine with another atom to form a molecules or a compound that is called as a atomicity. The number of atoms that is present in a molecule is called as atomicity. They are divided into four types. Monoatomic, these are the substance which contain only one atom in a neutral form in nature, that is called as monoatomic. Helium, neon, argon, these are the noble gases, inert gases. These are the monoatomic in nature. Where we are using these gases? Any idea? Helium, neon, argon. Yes, we are using in a light bulb. Helium, neon lights are there. Diatomic, molecules which contain two atoms are called as diatomic. Di means two. H2, N2, O2. These are the naturally occurring gases. Oxygen, hydrogen, nitrogen. But they are always available in a nature in a combined form, diatomic form, that is their stable form. Triatomic molecules which contains three atoms, it's called as triatomic molecules. O3 ozone, H2O that is the water. H2O consists of two hydrogen atom, one oxygen atom. So total three number of atoms, therefore it is a triatomic. They may contain same element or the different element. Polyatomic consists of more than three atoms altogether. P4, S8, sugar molecules, petroleum polymers are called as polyatomic, where component atoms are higher number. First, we are going to remember some basic terms. What is the atom? Atom is the smallest indivisible part of an element which carries all the properties of an element, called as atom. But it is consist of three major components called as electron, proton, neutron. Center part, neutron and proton located, while electrons revolve around a nucleus. Electron revolve around a nucleus in a particular path. That path is called as orbit. This is the first orbit. The capacity of the first orbit is 2 electron. This is the second orbit. Capacity of the second orbit is 8 electron. As like this, number of orbits increases, capacity is going to increase. This is the center part called as nucleus. Nucleus is always positive in nature due to proton is having positive charge, neutron is neutral in nature. Around the nucleus, the electrons are revolve Electrons are negative, so negatively charged revolve around a nucleus. Valence electron. The number of electrons present in the outermost orbit is called as valence electron. These electrons participate in a chemical reaction as well as determine physical and chemical property. Therefore, these electrons are called as valence electron. Valency. Valence electron participate in a chemical reaction that is called as a valency. We are going to learn in the next slide. Octet rule. The inert gases have a stable configuration of 8 electrons in their outermost orbit, except helium, which is having 2 electrons in the outer orbit, that is completing duplet. Due to the stable octet structure, these gases are inert in nature. What is meaning of the inert in nature? The capacity of outer orbital is 8 electrons. Out of 8 electrons, all 8 electrons are present. So they are completely satisfied. So they are not react or they are not interact with any other elements. So they have a stable structure. These are the inert in nature. Helium atomic number 2, and it is having only one orbit. First orbit capacity is 2. Out of 2 they are having 2 electrons, so they are having a completely filled duplet. So it is a inert in nature. The elements which is having less than 8 electrons in a outer orbit or the valence shell, valence electron, they have a tendency to attain electronic configuration of the nearest inert gas to form a stable configuration called as a stable octet or a duplet, 2 electrons. The number of electrons it accept or donate, it's called as its valency. They will achieve octet or stable configuration by gaining, sharing or losing of electron to complete the outermost orbital and become a stable configuration. The capacity of an atom described it by the total number of electrons lost, gain and share to complete its octet is determine the valency of an atom. Example that can be described by the electronic theory of valency. We will consider sodium atom, that is the denoted as Na. Atomic number is 11, means total 11 electrons are present. So configuration is 281. First orbit contain 2 electrons, second orbit contain 8 electrons, third orbit contain the 1 electron. So valence electron is 1. Outermost orbit contain 1 electron. To complete a stable, to get 8 electrons in a octet, sodium is try to lose this 1 electron and become a stable. So valency of a sodium is 1. Chlorine atomic number 17, configuration is 287. Valence electron 7. To complete octet, it required only 1 electron, so they will try to gain 1 electron and complete the octet. So valency is 1. Oxygen atomic number 8, configuration is 2 6. To complete octet, it required 2 electrons, so valency is 2. This chart explains you exactly how the valency determines by the configuration and how it is going to determine nature of components. First, sodium, atomic number 11, electronic configuration is 281. Outermost electron is 1, valence electron 1. So they are going to lose the 1 electron, valence is 1. Nature, sodium is metallic in nature because metals have a tendency to lose electron and become a electropositive. Magnesium, atomic number 12, configuration is 282, valence electron 2, valency is 2. They are going to lose 2 electrons and become electropositive. Aluminium, configuration is 283, valence electron 3. Aluminium is going to lose 3 electrons and become electropositive, and it is a metallic in nature. Silicon, atomic configuration is 284, valence electron is 4. So they are not losing electrons, they are not gaining electrons, mostly they are sharing electron. So they are showing some properties of metallic as well as non-metallic. So they are partially metallic and non-metallic, called as metalloid. Phosphorus, configuration is 285, valence electron 5. To complete octet, it is going to gain 3 electrons. As they are gaining negative charges, they are become electronegative. That is a property of non-metallics. Sulfur 286, gaining 2 electrons to complete octet. Chlorine 287, gaining 1 electron to complete octet, become electronegative, therefore non-metallic. Argon 288, valence electron is 8. Octet rule is satisfied, so they are not gaining, sharing electron, losing electron. So it is a inert in nature. Valence electron and valency determine chemical as well as physical property of an element. We are going to solve MCQ based on it. Charge on any ion depends on gain and loss of electron. Proton and neutron present in a center part, so the charges not depend upon the nucleus, charges depend upon the electrons. Noble gases exist as monoatomic, diatomic, polyatomic. Noble gases have a stable outermost orbit or completed octet, so they are always remain as a monoatomic. Tendency of atom to acquire 8 electrons in their valence shell is called as 8 means octa, it is called as octet rule. To form anion, non-metal atoms. Non-metal have a tendency to gain electron. As the electron is gaining, they are forming a negatively charged ion, that is called as anion. Answer is option B, gain electron. Next lecture, we are going to learn the chemical bonding, how the metals, elements, non-metal attach with each other by sharing and losing electron, that we are going to learn. We are going to learn 4 types of bonding. Ionic or electrovalent bond, that is obtained by loss and gain of electron. Covalent bond, by sharing of electrons. Coordinate bond, one-sided sharing of electron. Metallic bond, by delocalized electrons in a metal. Hydrogen bond, between hydrogen and electronegative atom. Thank you for your attention. Just go through this video again and again. If you have any doubt, you can mail me on my email address. Thank you so much.